All right, section 5, rank and row. Rank is a new definition. So first off, let's talk about row. So we're going to have row vectors. So it literally is the rows of a matrix, which we haven't done much with. We've mostly dealt with columns. So we're going to call the row space of A, row A. And the row A is going to be the same as column A transpose. So you know column A is the columns of our matrix A. And so if I take A transpose, those columns turn into rows. So the row of A would be the same thing as saying the column of A transpose. All right. So if two matrices are row equivalent, then their row spaces are the same. So if I have B as an echelon form or reduced row echelon, doesn't matter, then the non-zero rows of B form a basis for the row space of A as well as B. So whereas in column A you have to go back into the original matrix, row A you do not. All right, so if this is my matrix A and this is my matrix B, that's just in echelon form, I can find the pivots. So it's still about the pivots, just like column A is all about the pivots. So I see this is a pivot row. This is a pivot column. This is a pivot column, and this is a pivot column. So those are the rows that I'm going to identify that I need. And I'm just going to go back. I'm just going to use the rows that are in the echelon form. So this is a pivot column, so I'm using this row. So that's the first row. This is a pivot, so this second row I'm going to use. And this is a pivot, so this third row I'm going to use. So this is the basis for row A and for row B, if they're equivalent. So remember, for column A basis, you have to go back to the original matrix. So I want to go back to the original matrix for the first, second, and fourth column. And so I do that, and that is the basis for column A. All right, so to find null A basis, that's much harder. That's the one that takes a bit of work. So then taking this first row, and it gives us this information, augmenting it with 0, right? So I'm solving AX equals 0. So there's an extra 0 added on to this, and that's how I'm getting this equation. And so then x2 gives me this, right? So again, let me just make sure you're really clear. x1 plus x2 plus x3 plus x5 equals 0, because I'm solving AX equals 0. And so this first row gives me this. The second row augmented with 0 gives me this. The third row gives me this. And then I can see I've got 3 basic variables. And since I have 5 columns, I must have 2 free variables. And so I can see that x of 3 and x of 5 are my free variables. So again, I'm going to encourage you just to take this basic step so that you don't make any mistakes. X of 3 minus x of 5. 2x of 3 minus 3x of 5. X of 3 is itself. X of 4 is 5x of 5, and x of 5 is itself. So 5 entries, and then my 2 free variables are the ones that I'm going to factor out, right? So I get -1, 2, 1, 0, and 0. And factoring out at x of 5, -1, -3, 0, 5, and 1. Okay, so that's where those 2 vectors come from, was me doing all of this work. Remember, null A takes quite a bit of work.